Alright, so today I want to talk about eigenvectors and eigenvalues. So first, let's let A be an n by n matrix. And because it's an n by n matrix, we know that it's going to have n rows and it's going to have n columns. So since we have the same number of rows as we do columns, this is known as a square matrix. Now we're going to let the vector x be a non-zero n by 1 column vector. A non-zero n by 1 column vector. So because it's a column vector, it's going to have only one column, but it can have as many rows as it wants to. And we'll let lambda be a scalar. Now, because lambda is a scalar, that means that lambda is just going to be a real number. So, if all this is true, then if a times vector x is equal to lambda times vector x, that's the formula that you want to know, then we know that the vector x is an eigenvector of matrix A. It's an eigenvector of matrix A. And if that's true, then lambda is going to be called an eigenvalue of A. It's an eigenvalue of A. So an eigenvector is just a vector, and lambda, it's an eigenvalue, so it's just going to be a scalar or a real number. So let's go ahead and try an example. So let's let matrix A be 1, 4, 2, 3. So it's going to have two rows and it's going to have two columns. So we know that the dimensions are going to be two rows and two columns. And let's say our vector x is going to be a column vector, 1, 1. It's going to be a column vector 1, 1. So we know it's going to have one column and we know it's going to have two rows. So it's called a 2 by 1. Okay, so now let's go ahead and see if we can find a times x. So what we're going to do is we're going to put a on the left side, and we're going to put the column vector x on the right side. And we'll multiply these two matrices. Okay, so let's go ahead and choose red, and let's go ahead and circle the row, the first row, and let's circle the first column of the vector x. So now we can multiply this row by this column, and the way that we're going to do it is we're going to do component-wise multiplication. So we'll do 1 times 1 first, and that will give us 1. And then we'll do 4 times 1, and that's going to give us a 4. And if we do 1 plus 4, we get 5. So that'll be the first component of our matrix product. So now let's go ahead and circle the second row of matrix A. And we can only circle the first column of matrix X, right? So now we can do component-wise multiplication. So we'll do 2 times 1 first. That's going to give us 2. and then we'll do 3 times 1. That will give us 3. So 2 plus 3 will give me 5. So now I have the column matrix 5, 5. Well, if we remember from our formula earlier, we know that AX must be equal to lambda x. It has to be equal to lambda x, right? But we don't know what lambda is, so we'll just leave it as a variable for now. And we know that our x vector is going to be 1, 1 from up here. So now, if we multiply every number in this matrix by lambda, we'll get lambda and lambda. So now we can match our lambda with our column vector up here. And what this means is lambda must be equal to 5. So for our matrix A, we know that our eigenvalue is going to be a 5 when our eigenvector up here is 1, 1. So that's what eigenvectors and eigenvalues are all about.